Hello, everyone. Our continuation of the topic virtual clusters and resource management. Continuation now I am discussing here. The next further subtopic is fast deployment and effective scheduling. What ma? Fast deployment, fast delivering, and we want to see some effective in this is some fast efficient effective scheduling. What does it mean? In the sense, fast deployment and effective scheduling, in the sense, the system should have the capability of fast deployment. Means two things. How many things? Two things. To construct and distribute software stacks. Okay ma, to construct and distribute software stacks like operating systems, libraries and applications to a physical node, and this is to a physical node inside clusters as fast as possible, and to quickly switch runtime environments. Okay ma, to quickly switch runtime environments from one user's virtual clusters to another user's virtual cluster. If one user finishes using his system, the corresponding virtual cluster should shut down or suspend quickly to save the resources to run other virtual missions for other users. Okay, what the performance will be degraded. Okay, the performance will be degraded. Okay, what I does say, in the sense, first of all, if you have the fast deployment, means two things: to construct and distribute software stacks like nothing but operating system, libraries, applications to a physical node inside clusters as fast as possible, and to quickly switch runtime environments from one user's virtual cluster to another user's virtual cluster. If one user finishes using his system, the corresponding virtual cluster should shut down or quickly suspend to save the resource whatever to run the other virtual missions for other users. At the time, the performance, it will be degraded. Okay. What is nothing but green computing? What ma, we can learn about here the green computing. If one user finishes using his system, the corresponding virtual machine should shut down or suspend quickly to save the resources to run other virtual missions for other users. What we want to challenge here, in the sense, approaches have focused on saving the energy cost of components in a single workstation without a global vision. Consequently, we can say they do not necessarily reduce the power consumption of the whole cluster. They do not necessarily reduce the power consumption of the whole customer for whole cluster. Other cluster wide energy efficient techniques, it can only be applied to homogeneous workstations, and it should be specific applications. Okay, here we have seen the live migration of virtual missions. It allows the workloads of one node to transfer to another node. Okay, anything we can say, however, it does not guarantee that virtual missions can randomly migrate among themselves, potentially caused by live migrations of virtual missions. It cannot be ignored, so it may have some serious negative effects on cluster utilization and throughput and quality of service issues. Okay, now we can see the challenge. What the challenge is to determine how to design the migration strategies. Okay, how to design the migration strategies to implement green computing. What computing we can implement here? To implement green computing without influencing the performance of cluster, without influencing what the performance of cluster. We can take the another advantage of virtualization is nothing but the load balancing of applications, load balancing of applications in a virtual cluster. What that load balancing can be achieved in the sense, it can be load balancing can be achieved by using the load index, by using the load index and frequency of user logins and frequency of user logins. Okay, the load balancing can be achieved by using the load index and the frequency of user logins. Okay, so the automatically scale up or down the mechanism of a virtual cluster mechanism. What in the sense, some process, the process of a virtual cluster, it can be implemented by based, it can be implemented based on this model. Okay, consequently we can enhance the resource utilization of nodes and shorten and shortly the response time of systems. It is mapping with virtual missions onto the most appropriate physical node should promote the performance. What ma the response time of systems here, mapping of virtual missions onto the most suitable physical node, it should promote the performance. Dynamically we can adjusting the loads. Okay, dynamically we can adjusting the loads among the nodes by live migration of virtual missions is desired when the loads on cluster nodes it become the quite unbalanced. Okay, when the loads on cluster nodes it become quite unbalanced, in the sense we can see the high performance of virtual storage. Okay, now let us see the concept of high performance virtual storage. What does means high performance virtual storage here? What the high performance computing at a virtual storage, in a sense, we can take some the template virtual mission. The template virtual mission can be distributed to several physical hosts in the cluster to customize the virtual missions. We want to customize the virtual missions. The template can be the template virtual mission can be distributed to so many physical hosts in the cluster. In addition, we want to take some existing software packages. It can reduce the time for customization, as well as it will be switching to the virtual environments. And we have to store some virtual storage. It can have some storage architecture designs. It can be applied to decrease the duplicated blocks in a distributed file system of virtual clusters. Okay, so the hash values are used to compare the contents of data blocks. What more we can say here? The hash values are used to compare. We can see the comparison of what the content of data blocks. The users have their own profiles. The users have some their own profiles which store the identification of the data blocks for corresponding virtual missions in a user specific virtual cluster. Okay, user have some own profiles and they stored some identification of the data blocks. So we want to corresponding the virtual missions in a user specific virtual cluster. We can newly created the blocks are identified in the users profiles. In the users profiles we can create the blocks newly. It can be identified by the users profile. Okay, now we can see the performance of virtual storage. Basically we can see there are some 4 steps to deploy a group of virtual missions onto a target cluster. Okay, what we want to take some there are 4 steps to deploy a group of virtual missions onto a target cluster. First one we can take some preparing the disk image. We want to prepare what we want to preparing disk images, and we want to second one is to configuring the virtual missions, and third one is choosing the destination nodes. Okay, destination in the sense the final nodes we can choosing, and finally we can executing the virtual mission deployment command. Okay, virtual mission deployment command on every host. In the sense what we can say in the here in the sense many systems use templates, okay, to simplify the disk image preparation process. Okay, many systems use templates to simplify the disk image preparation process. So here a template is a disk image. Okay, template is a disk image that includes a pre-installed operating system, that includes a pre-installed operating system with or without certain application software. Okay, we can take some users choose a proper template according to their requirements, and they make a duplicate of it as their own disk image. Okay, what I can say in the sense we can choose a proper template according to the requirements, and we want to make a duplicate of it as their own disk image, and then we have to take some template, and that could be implement the cow format. What a cow in this sense is nothing but copy on write. Copy on write format. A new copy on write format, it is a backup file. It is very small, and it should be easy to create, and we want to transfer it. Therefore it definitely we can reduce some disk space consumption. Okay, in that addition we can say virtual mission deployment time is much shorter than that of copying the whole raw image file. Okay, every virtual mission is configured with a name and a disk image and a network setting and allocated CPU and memory. Finally we can say one needs to record each virtual mission configuration into an exact file. However, this method is inefficient when we are managing a large group of virtual missions. So the virtual missions with the same configuration, it could be use some predicted profiles to simplify the process. In this scenario we can say the system configures the virtual missions according to the chosen profile. What does the most configuration items by using the same settings. Okay, while some of them they take the while some of them they can took virtual mission name and IP address, it should be assigned with automatically we can calculate it that values. Okay, normally we can say the users do not care which host is running their virtual mission or not. Here we can see a strategy to choose the proper destination host for any virtual mission is needed. Okay, so the deployment principles is to fulfill the virtual mission requirement, and we need to balance the workloads among the whole host network. Okay, we can look at this concept of a high performance virtual storage. Finally, what we want to say in the sense, we want to maintain to record some each virtual mission configuration into files. However, this method is inefficient when we want to managing a large group of virtual missions. The virtual missions with the same configuration could use the predicted profiles to simplify the process. And finally we want to deployment the principle is to fulfill the virtual mission requirement, and we want to balance the workloads among the whole among the whole host network. Okay, and then we can finally discuss here the topic. The next one is live virtual mission migration steps and performance effects. Okay, what we can see, the next topic is what we have to discuss, live virtual mission migration steps and performance effects. Okay, what the live virtual mission migration steps, here we can look at this. In a cluster, we want to build with mixed nodes of host and guest operating systems. The normal method of operation is to run everything on the physical mission. In the sense, here we can discuss the normal method of operation. First of all, we can discuss here the normal method of operation is to run everything on the physical mission. In a cluster, we want to build with mixed nodes, okay, of host and as well as guest operating systems. When a virtual mission fails, its role could be replaced by another virtual mission on a different node. Okay, listen carefully. When a virtual mission fails, its role could be replaced by another virtual mission on a different node. Okay, on a different node, as long as they both run with the same guest operating system. But in other words, we want to say a physical node can fail over to a virtual mission on another host. This is some varying, in the sense this is different from physical to physical failover in a traditional physical cluster. Okay, in a traditional physical cluster. So the advantage is enhanced, in the sense increased the failover flexibility. Okay, failover flexibility. In we can say the drawback here. In other words, we can say a physical node can fail over to a virtual mission on another host. We want to take some drawback of this virtual mission. What does it do? The potential drawback is that a virtual mission must stop playing its role. Okay, must stop its playing its role if it's residing, in the sense inside, if it's residing host node fails. However, this problem can be mitigated with virtual mission live migration. Okay, however, this problem can be mitigated with virtual mission live migration. Okay, however, we can see here some live migration of the process. What the virtual mission from host A to host B, what it will be run, the migration copies, the virtual mission, what did it state, the file from the storage area to the host mission. Okay, now later we can discuss here, discuss in the diagram in further video. Thank you.